right, and we're back, everybody. Is that Nate Baker? That was Nate Baker. Nate Baker. All right, so solving compound inequality. So we sometimes, when working with inequalities, you're going to be restricted to two inequalities. Now, for example, let me ask you this question. If I said, okay, I wanted to find the people in my classroom that were either wearing glasses or wearing blue. Okay? Wearing glasses or wearing blue. Raise your hand if you're wearing glasses. Raise your hand if you're wearing blue. Everybody keep them up, keep them up, keep them up. Right? So this is all the people that are wearing glasses or wearing blue, right? So there's a difference between or. Now put your hands down. Now raise your hand if you have glasses on and are wearing blue. Okay. Yeah, I picked you up. You got blue on?
Got blue, right?
Yeah. So there's a difference between or and. You know, mathematically too, there's a difference between or and. Today we're going to compare two inequalities using those words, saying, you know, it's got to be less than 5 and bigger than -1, right? So it kind of restricts our boundaries a little bit. Now, if I said it's got to be bigger than 4 or less than -1, well, then it could be either one or the other, just like you could be wearing blue or you could have glasses on. You could still meet the requirements. So we have this idea of having or and. Okay? And they come up using compound inequalities. The inequalities you have seen so far are what are called simple inequalities because they only have one inequality symbol going on. When two simple inequalities are combined into one statement using the word and or, the result is called what's known as a compound inequality. Okay, I guess I should leave this here. All real numbers greater than 2 and less than 6. So notice how I use the word and. Greater than 2 and less than 6. When I use that terminology of saying the word and, it must fit both requirements. Greater than 2 and less than 6. Take a look at the graph and copy that down into your guided notes, please. That's what an and graph will look like, where they will connect in the middle. You know, if I just wanted all numbers greater than 2, you know, 3, 4, 5, 6, 7, 8, 9, 10, up and so on, right? But if I restrict that to say greater than 2 and less than 6, well, now I have to cap it at 6, right? 7 is greater than 2, but it's not less than 6. So I have to restrict it a little bit more. This is the way I box this, please. This is the way I'd like you to write all and inequalities, where it's one statement with two less than symbols in it. Remember that anywhere where the line goes over, that's really the solution in there. Like, for example, is 4 a solution? Yes, because it is greater than 2 and still less than 6. Would 7 be a solution? No, because even though it's greater than 2, it is not less than 6. It's got to be in between 2 and 6. The rules about open or closed dots still apply. Okay. If I put the or equal to's, obviously I just fill in those dots. So go ahead and copy this one down too. If I say all numbers greater than or equal to 2 and less than or equal to 6, again, box this please with the one single statement. Mr. Mitchell. Wow.
Oh, damn, man.
Yeah, man, I'm looking at you all that. But you don't break.
Still can't tell who's very elaborate. He's on Friday.
What's the monotone?
Nothing.
You're like I was gonna give donuts for the most participating class. There was like 2 people in this class. 3, excuse me.
You know, I forgot a meeting this morning, so
Are you serious?
it's not like I was going to remember that this week was Fair Week. I'm creating meetings.
Hey, what are you gonna do tomorrow for the trending Tuesday?
I mean, I'm trending, so basically I'm just gonna dress up as myself and everything works.
Got it.
Now, really, I wanna dress up as Nate.
See trending. There you go. That's trending in the wrong direction.
Oh, what are we talking about here?
Compound inequalities.
Are these the things that certain students?
Just know that you are being recorded right now. Everything you say is being recorded. And will be.
Hello, absent people. So are these the things that I taught incorrectly, even though we never talk about them during 8th grade math? See? No. Chance.
Oh, that's right, Chance.
So that I taught it wrong, but we don't.
Yeah. Chance was like, oh, Mr. Smileton, he taught us wrong with these inequalities. He's like, he told me that, if it was an open, it was or equal to.
No, we don't even talk about that. Okay, continue on.
Okay.
I'm learning too.
All right. So if I want all numbers less than 2 or greater than 6, this is that idea of having, wearing blue or wearing glasses, right? When we had a lot of people's hands up, right? This is one or the other. It doesn't need to meet both criteria, just one of the two. It could either be less than 2 or greater than 6. It doesn't have to be both. Can anything be less than 2 and greater than 6? No. So an and wouldn't even make sense here, because I can't be less than 2 and bigger than 6 at the same time. Now, notice that there's no other notation here. I can't combine it into one statement. I've got to use the word or. I actually write the word or within my answer. Negative x is less than 2 or x is greater than 6. Notice that again, it's the inequalities, that rule still applies, whether it's the greater than or less than. Those are the open dots or equal to's, fill in the dots. Obviously here, filling in the dots with the or equal to's, right? X is less than or equal to 2, or x is greater than or equal to 6. So again, with these compound, yes, sir.
So Albert, what if I had an or situation, but they were both pointing the same way?
That's a great question. So if I had x is less than 2, or x is greater than 5. Oh, no. Let's say negative 5, right? What would happen here? Well, think about the graph of x is less than 2. Okay, this is x is less than 2. Here's 0, here's 2, open dot at 2, going to the left, right? Correct? But what about the graph of x is greater than negative 5? So negative 5 would be somewhere over here. Open circle, going this way. So what would I say about my solution? If it just has to meet one criteria, it just has to meet one of these things, what would I say about my solutions? Let me ask you this. Is negative 1 a solution to this? Yes, right? And it only has to meet one criteria if it's an or, right? What about negative 10? That's a solution here. Does it matter that it's not here? No, because this is an or. What about negative 100? What about negative 1,000,000? Right? What about 3? Is 3 a solution here? No, but is it here? Yes. What about 5? What about 100? What about 1,000,000? So, what do you think? All real numbers. Interesting question. Now, more often than not, though, more often than not, ors will point out and ands point in. Okay? Ands point in toward each other, ors point out away from each other. I think of it like the oars on a boat. Oars usually point away from each other. It's like these are your handles of the boat, or the oars, and then it's like, yeah, okay. There you go. All right, let's just start here. You can pass up that intersection thing. Let's just jump back down to the example. Is this an and or an or inequality? This is an and, right? Because it's written in that one single statement. Guys, if you don't see the word or if you see no words at all, it's an and. Now, how do we solve this? Well, how would we solve for x? Consider this. Consider the following. How would I solve that? Subtract 1. How would I solve this? So if I'm doing the same thing, can't I solve them both in the same way at the same time? Yeah. So here's what we do. Since I'm going to subtract 1 here, I not only have to subtract it to the far left, but I also have to subtract it to the far right. Okay. So that gets me a -6 is less than x is in the middle, g stands alone, we have 1. You not only have to subtract it away from the inside, but you have to subtract it away from both the left and the right side as well. Okay, so now when I go to graph this, since this is an and inequality, I've got -6 and +1. See, now this time, I don't need to have the 0 in because I've got both of my endpoints on there. So I don't need to have the 0 written as well. Are these going to be open or closed dots? Open dots. Now, are they going to connect in the middle or go away from each other? They're going to connect in the middle. This is an and inequality. They're going to connect in the middle because this is like saying x is greater than -6 and x is less than 1. You can read it both forward and backwards, going from the middle out. Okay. Would 0 be a solution? Yes. Would 5 be a solution? +5. Would +5 be a solution? No. Let's keep it going. Okay. We solve this like we're only solving one of these sides. But we're going to solve it both at the same time because it'll save us time. What gets x alone in the middle here? What gets x alone?
Divide by 3.
Ooh, don't divide by 3 yet. Carson?
Add 1.
Add 1 to both, all sides, right? Add 1 here, add 1 here, add 1 here. So we get 9 is less than 3x is less than or equal to 12. Now I divide by 3. Now I divide by 3 to all parts. 3 is less than x is less than or equal to 4. Again, this is an and inequality, so it will point in toward each other. It will point in. So here's my number line. Here's 3. Here's 4. Open on 3, but closed on 4. Connecting in. Yes, that can happen where you can have open on one end and not on the other. Now, the or inequality. Okay, the or inequality. That's what's known as a union. The other one was an intersection. This one is a union. But basically, that's just fancy talk for saying that it could be one or the other, right? This is showing x is less than 10 or x is greater than, x is less than 0 or greater than 10. X is less than 0 or greater than 10. So it could be one or the other. It doesn't need to be both. Let's look at the examples here. Now, when you've got an or, yeah, sorry, Carson.
Could you just solve 1 and not the other if 3 plus 1 and you use 1?
Well, but they might give you different boundary lines. Like here, if I solved just this one, if I just solved this one, I subtract 8 from both sides, t is greater than or equal to -1. Well, then where's the other boundary on t? You know what I mean? We just have one of these. So now if I subtract 6, okay, t could also be less than -4 as well. Does that make sense? So you've got to know both of the restrictions on it because it's going to give you both of the options that you could have. It could be greater than or equal to -1 or still still less than -4.
Then you could use just 1.
Well, but we graph them both. So we have -4 and -1. I've got a closed dot on -1 going to the right. I've got an open dot on -4 going to the left. Oars point out. Oars point out. Just like on a boat. Oars point out. If they point in, something weird has happened, like that question that Mrs. Paulson asked. So we solve them both separately, and then we graph them on the same number line. It's Monday. Take a look at this one. 4x is less than or equal to 20, or 3x is greater than 21. See, these are pretty easy to solve. I'm just going to solve, it's like getting a 2-for-1 deal. You get 2 problems for the price of 1 problem. 2 equations for the price of 1 problem. So x is less than or equal to 5, or x is greater than 7. Okay, so we've got 5 and 7. It's a closed dot on 5 going to the left. It's an open dot at 7 going to the right. I am still using my rules about the direction of the symbol is going to tell me where to put my arrow. Guys, is 6 a solution here?
No.
No, it's not being covered up by either arrow, is it? 6 is not less than or equal to 5, and it's not bigger than 7. So that's one of the only numbers that doesn't work here. And now what we're going to do is we're going to flip it around. Okay, we're going to flip it around. Write the compound inequality shown by the graph. Okay, so now I'm giving you the graph and asking you to write the inequality. Okay, so is this an and or an or? It's an and, right? And I know ands are always set up like this. Now, do I have to add in the or equal to's, or do I leave them as less than? I leave them as less than. Both of these are open dots. My left side boundary is -9. My right side boundary is -2. And there's my answer. The ands are always going to be less than symbols. They're always going to be less than symbols. I'll pull up the other one here. Is this an and or an or? This is an or. So I'm going to write the word or in it, and then I'm going to treat it as 2 separate things, 2 separate pieces. This is less than or equal to -3. This is greater than or equal to 2. Sorry, I knew I was going to hit it right at the end there. Make sure you write down your homework.
Homework.
Oh, I forgot to stop the recording.
Yeah, that was probably being recorded.